Hello and welcome to Bio Affairs. Today I'll be teaching you ELISA. I will start from the basics and I'll go for the types as well as the mechanisms. So what is ELISA? ELISA is known as enzyme linked immunosorbent assay. So as the name suggests, there is an enzyme which is linked to a immunosorbent. Immunosorbent here in the sense of antibodies or antigens you can say. And it is linked together to form the total assay. Now, the ELISA consists of few components. What are the components? First, the word immunosorbent, let me clear you. Immunosorbent is suppose the wells, the microtiter wells which are used for ELISA, it is made up of polyvinyl or polystyrene components, which are basically designed to absorb the immunosorbents, which are antigen or antibody. So these polyvinyl or polystyrene plates or individual microtiter wells will be absorbing antigen and antibody to give you the desired structure or the desired results depending upon the findings. Now next is enzyme. So here in this assay you can use several enzymes, but all the enzymes, as you know, the substrates are different. So very commonly used is horseradish peroxidase. The substrate for this enzyme is H2O2, that is hydrogen peroxide. In case of beta-galactosidase, the substrate is ONPG, orthonitrophenyl galactoside. Alkaline phosphatase, which is also a very commonly used enzyme, the substrate for this is para-nitrophenyl, PNPP. So these enzymes, another enzyme you can write, that is urease, which acts upon urea. So these are the few common enzymes which are used in the ELISA procedure, and their substrates are different. Here one next component I will say chromogen and substrate. So this enzyme will work upon these substrates. Okay, now these substrates will either activate the chromogen. Chromogen is the component which actually gives you the color, because ultimately after the performance of ELISA procedure you are going to measure the optical density through the change of color with positive or negative or high positive or medium positive or low positive. So anything will be compared based upon the optical density, and that color formation is done by chromogens. So sometimes the substrates activate the chromogen, or this chromogens or the substrate itself act as a chromogen. So in case of substrate and system, I will give you a chart of commonly used these enzymes, their substrates and the chromogens. Okay, like this. Here the chromogen is TMB. Here the chromogen is bromocresol. In these two cases, the substrate itself is chromogen. So the substrate itself can act as or the product act itself as a chromogen, which will give you the color. So now, as you have understood, ELISA consists of three systems: the immunosorbent, the enzymes, the chromogen substrate system. This is the total procedure or the total components. Okay, so immunosorbent signifies antigen antibody, enzymes signifies the enzymes which will be converting the substrate to give you the actual color formation, to determine either the person is positive for the antigen or antibody or negative for the antigen or antibody. Okay, now The types of ELISA. So ELISA can be of 4 types: direct, indirect, sandwich, and competitive. So direct ELISA is commonly used for antigen detection. Okay. In case of indirect ELISA, it can be used for antigen and antibody detection. Whereas the sandwich ELISA is used for antigen detection. And the competitive ELISA can be used for both for the detection of antigen and antibody. So I will be going in one class. It is not possible to complete all the procedures. So one by one, next part to next part, I will be covering direct, indirect. Today I will be telling you about direct. From the next class, I will be telling you about indirect, sandwich, competitive. Slowly. Okay, so that you can understand. These are the few enzymes, substrate, and chromogens. As a chart format I have given you. So HRP or horse peroxidase, which works upon hydrogen peroxide, and the chromogen used here is tetramethylbenzidine. In case of alkaline phosphatase, the substrate used is para-nitrophenyl phosphate or PNPP, which upon acting by this alkaline phosphatase can be produced by, the product is the para-nitrophenol, which itself is a chromogen. In case of beta-galactosidase, ONPG, orthonitrophenyl beta-galactoside, is used. ONPG also can act as the product of ONPG after acting by the enzyme can act as a chromogen. That is, here orthonitrophenol is produced, which itself gives color. Now in case of urease enzyme, the substrate is urea and the chromogen used was bromocresol. So remember that in each individual ELISA, a single enzyme will be used, a single substrate will be used, and a single chromogen will be there. Okay. Now let's go to the direct ELISA. So let's understand the direct ELISA. So in case of direct ELISA, this is the PV, polyvinyl, or PS, I am writing microtiter well, means there is a 96 wells are present in a plate. I am just drawing here one well from the 96 well. Now this polyvinyl or polystyrene made up of wells first will be empty. In case of direct ELISA, there will be no antigen or no antibody attached to the microtiter well. Now in case of direct ELISA, patient serum will be given directly to the empty microtiter well. Now here we are going for the detection of what? Antigen. So if the patient is positive for the antigen, then it will give a positive result. If it is negative, then it will be a negative result. So I am describing the procedure here. How will you understand positive or negative? So suppose the patient serum, which I am going to diagnose, contains the antigen. Any antigen, any pathogen you say. Okay. So these are the dotted or circles I have seen. These are the antigens. Okay. These antigens means after giving the serum, that PV or PS styrene microtiter wells will be incubated for very long period. Suppose it is incubated for overnight or maybe 8 to 10 hours, depending upon the company which standardizes the protocol upon the diagnosis. So after overnight incubation, if the patient serum contains the antigen, it will be adhered to the wall of the microtiter wells. So basically the antigens adhere to, or the desired zone of adherence is the basal level of the wells. Okay. Now we have to wash after the incubation. So after each incubation period, you have to wash the microtiter wells very carefully. Otherwise, it will give you a false negative or false positive result. I will tell you why and how. Suppose after overnight incubation, you are not washing the wells. Okay. So if the patient serum contains more amount or more concentrated antigens, if you are not washing them, it will be presence of more amount of antigens there. Okay, that will give you a high positive, or from if the patient is low positive, it will give you a high positive result. Or in case of patient which have a very less antigen, or may not have the particular antigen from the particular pathogen, it may give you a false positive result. Okay, because it may cross react and give you a false positive result. So that's why after every incubation period you have to wash the microtiter well. So after washing the wells, the unadhered antigens will be washed away. So now I have the adhered antigens to the walls. Into that antigen I have to give now primary antibodies. Remember, in direct ELISA only one antibody is used. Only one antibody is used. This is very important. Now this antibody which will be used here will be linked with enzymes, not several enzymes, linked with a single enzyme. The enzyme may be, as I have shown you the chart, it can be of any enzyme, but the antibody will be linked with the enzyme. Now this enzyme or the antibody is specific to the antigen which I am going to diagnose, or for which pathogen I am going to use it. So this antibody, the primary antibody I am telling here, will be attached to the antigens present in the well. Now after that you have to again incubate for some period. It will be written by the company manual. You have to follow that. So after adherence, after a few minutes, you have to wash the wells again. Okay, because if there is no antigen and you keep the antibody there with enzyme, when you give the substrate, it will give you color, so it will give you a false positive result again. So after washing, if there are antigens, antibodies will be present there, as all the antibodies now bound to the antigen, and if it is the patient serum is negative for the antigens, all the antibodies will be washed away. Okay. Now after that, after a few periods or after a few minutes, you have to add the substrate. Which substrate? That is specific for this enzyme. Okay. Now this enzyme substrate, what enzyme will do what? Enzyme will convert the substrate into product, some kind of product which will itself act as a chromogen. Okay. So that chromogen will give you the color. Okay. That will be in the formation of product. So if the patient serum is positive for the antigen, the product will form and it will give you a color which will be measured by spectrophotometer or colorimetric assimilation or assay findings. So this color formation will be measured by spectrophotometer in the sense of optical density or OD values. Now after the formation of, or after 1 to 2 minutes of incubation, after giving the substrate, you have to add the stop solution. Stop solution is very important component of ELISA, which is generally 1 to 2% of H2SO4. This stop solution will stop the enzymatic activity then and there, so that it will not produce the more and more color which will give you from low positive to high positive of a strong reaction. So this is very important. At a particular point after incubation, you have to add the stop solution. Otherwise, a weakly positive sample can show you a strong positive result. Okay, that will confuse the interpretation of the sample. So I hope you understand that direct ELISA consists of mainly only one antibody which is linked with enzyme. Antigen will be not adhered from the previous one, or company will provide you only the microtiter well which is devoid of any kind of antigen antibody. So first session serum, then antibody, then substrate which will be formed to the product, and then stop solution. So the color formation will be measured in the formation of or in the measurement of OD. So generally ELISA washers and ELISA readers are used to measure the result at a time. So I hope this class is clear to you. If you have any doubts, kindly comment me, or you can mail me, or you can join my Telegram channel, which is also given link there. Thank you very much for your patience, and if you have any kind of query, kindly do the comment section. So next class I will be following indirect ELISA, then sandwich ELISA, and then competitive ELISA. So if you like my classes, give a big thumbs up and don't forget to subscribe my channel, because these things stimulate me to take futuristic classes for you guys. So thank you and be with me.